So having seen some examples of machine learning, let's look at two specific problems in the area, regression and classification. What are the typical situations where we try to apply machine learning? Usually, we are trying to extrapolate from past data to future unknown situations. We are trying to predict the future from the past. One example would be when schools ask their students who are writing board exams to go through some mock tests before the board exam. These mock tests provide practice, no doubt, but one important reason to ask students to do these mock tests is to predict whether they're going to do well in the board exam or not. Given the historical information about how students have done in the past in mock tests and then in the subsequent board exams, a school can decide whether a given student in this year's exam should be allowed to write the board exam or not based on how he or she has done in the mock test. So in this example, we're trying to predict the performance of a student based on a model we have arrived at from historical information about students in the past. Another instance is a bank which has to decide whether a customer is worthy of a loan or not. Each customer comes with some information about their financial background, their salary, their assets, and so on. An experienced bank manager weighs all this evidence to decide whether to give a loan or not. In our situation, instead of relying on the experience of the bank manager, we would like to go with the historical information that we have from past loans to decide whether or not the current customer's statistics about their various financial parameters determine their loan worthiness or not. And a final familiar example is what happens when we fall ill. We are feeling unwell, we don't know what's wrong with us, we go and see a doctor. The doctor asks about our symptoms, maybe asks us to do some tests, and comes up with a diagnosis. So, what the doctor is doing is trying to predict what disease we have based on the symptoms that he or she observes and based on the past information that the doctor has about patients who have come with similar symptoms. So, we are being diagnosed based on a predictive model which comes from the experience of the doctor and the training of the doctor. So in all these situations, what we are doing is we are using historical data in order to classify new data. We get some new student, we get a new customer, and we want to decide whether the student will pass, whether the customer should get a loan, whether this patient has a disease or not. In the case of the student, for instance, this classification is based on first predicting a number. How many marks is the student likely to get? Based on how many marks the student will get, we then decide whether the student is likely to pass or not. Broadly, this is called supervised learning. So in supervised learning, we have historical data which has been labeled. So for the past items, we know the category. We know whether the person got a loan or not. We know whether the student passed or not. We know whether the patient had this disease or not. So this data has been manually labeled. We are then going to use this manually labeled data to predict the unknown outcome for some new data item. We do this by building a model. So we build a mathematical model which builds on the data that we have to predict the outcome for an input that we have not seen before. So what are we trying to predict? One category of predictions are numbers. One example we have already seen is exam scores. We want to know, for example, maybe the percentage that a student will get in the board exam based on the percentage they've got in the mock exam. Or it could be that we work for an insurance company and we want to validate whether the house that we are insuring is worth the amount it's being insured for. So we want to predict the price of the house, knowing some information such as maybe the age of the construction, the size of the house, the total built up area, the location, the part of the city where the house is, and so on. And we use historical information that we have about such houses in order to determine what is a fair price for the house that we are trying to insure now. And coming back to the bank loan example, we might make our assessment based on some overall calculation of the net worth. So we have the salary, the assets, and so on, and we want to decide the paying capacity of the customer. And based on that, we will give a loan. So in all these cases, we are trying to predict a numerical answer based on past numerical answers. So for this category of problems, typically the approach that we take is something called regression. On the other hand, when we have categorical answers, we are trying to say yes or no, good or bad. An example is a junk filter. We all have seen when we use email clients that some mail is classified as junk. So this is something which takes a look at the text that comes through the mailbox and decides whether or not this is to be read by you or to be put aside and perhaps thrown away without reading. So how is this done? It's based on some analysis of who it is from, how long the message is, what the message contains, and so on. But this is not a one size fits all thing. So you do have the capacity to adapt this filter by saying that some junk mail that you have got is not junk, or vice versa. Some mail which has passed through the filter and come into your inbox is actually junk. Back to insurance. When an insurance claims comes in, the company must decide whether to pay out this claim or to contest it. Do we have to investigate it? Is it fraudulent? So again, based on the parameters surrounding the claim, such as how long ago the insurance policy was made, how much it is for, what are the circumstances of the claim, the company may find it expensive to investigate every claim for fraud. On the other hand, an algorithm can decide whether a given claim that comes based on historical evidence is likely to be good or bad. Finally, consider the case where you apply for a credit card. You may be rejected based on your financial background, or you may be approved. And if you are approved and you have an exceptionally good record, you might get a premium card instead of a normal card. So in this case, we are trying to take each application and classify it not as good or bad, but as reject, normal, or premium. It's a multi-way classification. But notice that we've already said we could do it in two steps. We could first decide whether to reject or accept the application. And if we accept the application, then we decide whether it's a normal card or a premium card. So this is a typical situation which explains why we can always assume we only do a binary classification, and then by repeatedly doing binary classifications, we can do a multi-way classification. So the models that we will look at for classification will typically do only a yes, no, or a good, bad type of classification, but it does not affect the generality of the situation. So what are we doing when we try to predict these answers? We are first building a model. There are different models depending on whether we have to do some kind of regression, whether we're trying to predict a number, or whether we're trying to classification, we're trying to predict a category. Each model is determined by some set of parameters and we need to find these parameters. So how do we find them? Well, we fit the parameters based on this historical input. Now, even if we are building the same type of model, each time we feed it different data, we get a different model. This is why each person's junk mail filter is different from the other person's, because each of us feeds mail to this filter in different ways. Some things which one person considers junk may not be considered junk by another person. Schematically, we have this picture. So we have a learning algorithm which takes as input a template for a model, what type of model we are trying to build. Then it takes a lot of historical data. This is labeled data where we have for each input, we have it's a yes or no or good or bad. And using this sequence of inputs, the model is tuned. We fit the parameters and we come out with an actual predictive model. So notice that the actual model will depend on the data. So the template may be the same, but with different historical data, we will produce different predictive models. So what we will be doing as we go along is to study some of these models and also try to understand how it is that the historical data allows us to determine the parameters and build a specific model from the broad template that we have for this model.